Adjunct Professor Moran, Macroeconomics 111, and we're going to use the information we developed in our last session concerning gross domestic product and aggregate expenditures. We determined our current level of equilibrium. We also determined the marginal propensity to consume, the marginal propensity to save, and determined the multipliers of 4 and 3, spending multiplier, tax multiplier, balanced budget multiplier. So we discover from the problem that full employment is at 590. Equilibrium would be at 590 aggregate expenditures. But from our last problem, we determined that our equilibrium, our current actual equilibrium, is 490. Gross domestic product actual, aggregate expenditures actual, 490. Any number that hits the 45 reference line has the same value on both sides. We'll label this aggregate expenditures full employment and aggregate expenditures actual. You can see that because actual GDP is closer to the origin than full employment, we aren't producing enough output to generate full employment. So the government, it could be any one of the four variables, C, I, G, G, X, N, but the government accepts responsibility for returning the economy to full employment. And the question is, how much does government have to spend to get us all the way back to 590 full employment? So we're going to use the multiplier to determine what the change in government spending is going to have to be to restore us to full employment equilibrium. There are three multipliers: a spending multiplier, a tax multiplier, and a balanced budget multiplier. So there are different ways the government can get us there. We know that GDP has to change by 100. 590 minus 490. We don't know how much the change in aggregate expenditures is going to be, and the government will accept responsibility for this. And we know that the spending multiplier is 4. We determine the marginal propensity to consume by taking the change in consumption, and then, which was change in consumption was 15 every time income changed by 20, and that turned out to be 0.75. We need the marginal propensity to save for the spending multiplier, and so if the marginal propensity to consume is 0.75, the marginal propensity to save is 0.25. 1 divided by 0.25 gives us a spending multiplier of 4. The tax multiplier is a negative marginal propensity to consume divided by marginal propensity to save. 0.75 divided by 0.25 is a negative 3. And the balanced budget multiplier is 4 minus 3, always equals 1. This will always be 1 less than the spending multiplier, and a negative 4. So this reduces to 25. This solves to 25. So if the government spends 25, that will be repeated. There'll be like echoes of it. It will multiply throughout the economy until the total change in GDP is 25 plus another 75, restoring us to full employment. Now, how does this work? When the government changes spending by 25, it takes us to it's a shift in the aggregate expense line. This curve is shifting up. And now we have a disequilibrium. We have 490 plus 25. That's 515. 515 aggregate expenditures compared to GDP of 490. Anything on this side of the 45-degree reference line is larger than anything on this side of the 45-degree reference line. Buying, think of aggregate expenditures as buying, the expense approach, and think of GDP as making, output, and income. The three different measures of GDP are now on the graph. So now, aggregate expenditures are larger than GDP, buying is greater than making. There's an unplanned inventory decrease, which sounds bad, but it's good for business because they're selling more than they thought they were going to. So businesses will respond by producing more. They'll need more workers. Unemployment will fall. Income rises. And since income is the primary explainer of changes in consumption, consumption will rise. But consumption doesn't rise dollar for dollar, or this would be a 45-degree reference line. No. The marginal propensity to consume is 0.75. The marginal propensity to save is 0.25. So you'll go up based on the slope of the consumption line. The slope of this is the marginal propensity to consume, which is 0.75. And business will continue to increase production until, and income will continue to rise until buying is equal to making at the equilibrium. So government spending will whack us out of equilibrium, cause a disequilibrium where people will want to buy more, and income will go up, unemployment will go down. We'll get to this new equilibrium. If we wanted to accomplish the same goal, but instead of using the change in government spending, the government could reduce taxes. We still want government spending we still want GDP to change by 100 in all three. We don't know how much we need to change taxes. That's what we want to solve for. We do know that the tax multiplier is a -3. Solving the problem, solving for change in T, a tax cut of 33 will cause disposable income to rise. Right? The formula is personal income minus taxes is disposable income, which is then consumed or saved. So by lowering taxes, disposable income goes up, and so does consumption and savings. So a tax change of 33.3 will cause a change in GDP of 100. Notice that the change in taxes has to be larger than a change in government spending, because the change in government spending is immediately counted as a change in GDP, whereas a change in taxes is a transfer payment, which doesn't count in GDP. And part of the tax change will be consumed, but part will be saved. Savings is a leakage, which exits the expense stream and does not count as GDP. So to get the same change in output, a change in taxes has to be larger than the change in government spending. The balanced budget multiplier is always 1. So if you were going to stimulate the economy to fight a recession, you'd have to increase government spending. But if there's a balanced budget multiplier, you also have to increase taxes. The change in government spending would multiply by 4 times, but the change in taxes would be contractionary of 3. So that would net out to a change of 1. The government would have to spend all 100 to get us back to full employment, which in practical terms is not possible. It would destroy the government's ability to manage the economy. So that's the con side of recommending a balanced budget amendment, which some people feel we have because the government doesn't seem to be able to control its spending. The government is consistently running deficits. So we've used the information that we developed to determine actual GDP. We determined the marginal propensity to consume, the marginal propensity to save, and we determined the multipliers. Then we compared our actual to full employment and determined how much we were short. And then we used the 3 multipliers to determine how much government spending would have to change, how much tax would have to change, how much the balanced budget would have to change to restore recessionary equilibrium to a full employment equilibrium. This gap here, if you remember from a prior lesson, is known as a recessionary equilibrium. An inflationary equilibrium is if the actual equilibrium were here, maybe at 690. Now our actual GDP is larger than our full employment GDP, and this gap would be an inflationary equilibrium. Notice that from a spending point of view, the amount of the inflationary gap will turn out to be the amount that the government needs to change spending by to restore the economy to full employment. So this would be a change in government spending in a recession, and this would be the invisible hand which returns us to equilibrium.